solve linear systems by graphing. As we talk about linear systems, we're going to talk about how to solve these in three different ways. And the first way is going to be graphing. All right, so our objective here, solve a system of linear equations in two variables by graphing. So what do we know that's going to help us? Well, we know what a linear system or a system of linear equations is. It is two or more linear equations working together. For example, here is a linear system with two unknowns, x plus y equals 7 and x minus y equals -1. Okay, so as far as graphing is concerned, since we're talking about linear equations in two variables, we're talking about lines, x's and y's, and we're creating lines on a graph. So we can determine the solution, which will be on a graph, the point of intersection, and which we learned in a previous video is the point that satisfies both equations by graphing the two equations. Okay, and we're going to be using our TIs to do that. Let me slide this up here. Okay, and in the TI, we need to first set each equation equal to y, because the TI is a y equals graphing calculator. So example 1 here, solve the linear system by graphing. Our first, and I'll label it with a 1, our first equation, 2x minus 3y equals -4. And our second equation, which I'll label with a 2, 2x plus y equals 4. So we want to solve this by graphing. Okay, well again, with the TI, we need to first solve these equations for y. So let's look at equation 1. Equation 1 is 2x minus 3y equals -4. I'm going to subtract 2x from both sides. 3y is -2x minus 4. I'm going to divide both sides by 3. I'm not going to worry about distributing the 3. I'm just going to write -2x minus 4, divide by -3 over -3. Now I realize this is not in slope-intercept form. If you want to write it in slope-intercept form, you can do that. What's important is that you have solved it correctly for y, because if we put this in the TI, we will get a line. We will get it to graph the line we're looking for. Let's do the same thing with equation number 2, which is right here. And this is 2x plus y equals 4. I want to solve this for y, so I'll subtract 2x from both sides. And I have -2x plus 4. And that one was a step simpler. Okay, so now I have two equations that have both been solved for y. I can now graph them using the TI. Okay, so let's go into here and go into my graphing. Oops, I'm in Zoom. Let's go to y equals. Equation 1, I'm going to make use of the fraction bar. Equation 1 was -2x minus 4, all divided by 3. All divided by -3. I've missed that -3 twice. Equation 2 was -2x plus 4. And I think I'm in the standard window. I'll press graph. In my case, the blue line is equation number 1. And the red line coming up shortly, there's equation number 2. Okay, so there's my first one. There's my second one. When you're graphing, the solution is where they intersect. Okay, so now how do I get the calculator to find that intersection point? Well, I go to calc right here, so second calc, and I choose number 5, intersect. Let's note that on our paper. We're going calc, and then we're going to number 5, intersect. Now the TI, so go down to 5, the TI first wants to make sure that it knows the two lines you're talking about in case there are more than two lines. So is this the first curve on the blue? Yes, it is. I'll press enter. Is this the second line? It's asking me right here. Yes, it is. It's the red one. I'll press enter. Would you like me to guess or tell me the answer? The answer is yes. I'll press enter again. And it says it intersects at the point 1, 2. So the solution set, okay, the solution is the ordered pair one, 2, and we're done. Now, in case you make a calculator mistake, it probably makes sense to make sure that our ordered pair is indeed a solution to both of these equations, and you can do that with your calculator. I think if you're careful and you've done the algebra correctly to solve for y, you should be fine. But yes, it's never a question, is this the solution? Because you can check this. You can check this in equation 1. You can check this in equation 2. And if it works for both, then you indeed have the solution 1, 2. Okay, so let's talk about lines briefly, then take a look at 2 other examples. In most cases, when you have 2 lines, they simply cross at one point, or they intersect at one point. However, sometimes the 2 lines can be parallel, and so here's an example of parallel lines. Or the lines could be what's called coincidental, which means they are lying upon one another. So here are 2 lines, and the first line is lying on top of the second. This is the most popular, of course, when you have 2 lines, but they could be 2 lines that are parallel, or they could be 2 lines that are on top of one another. And in the first case, if the 2 lines intersect, there's only going to be one ordered pair solution, and it's the intersection point right there. Okay? If the 2 lines are parallel, well, they never touch. Therefore, there is no solution. Okay? If the 2 lines are coincidental, again, that means they're lying upon one another. Well, that means they touch everywhere. There are an infinite number of touches, which means there are infinitely many solutions to the system of linear equations. Okay, so we want to remember this is how 2 lines can wind up. We just did an example of this one right here where they intersect at one point. Let's do examples of this one and this one to see what happens. Turn my paper over. Okay, and let's take a look at example 2 here. Solve this system by graphing. Again, I'm going to label this as equation 1 and equation 2 because I need to solve them for y first in order to graph them in my TI calculator. So 4x plus 6y is equal to 12. Let's subtract 4x from both sides. 6y is equal to negative 4x plus 12. Let me get my notes together here, make sure I'm following through correctly. And then I can divide both sides by y. Again, I'm not going to get particular. I'm just going to divide the right side by y and leave it just like that. I don't need to get, again, you can, if you want to distribute the y, because it's a common denominator, and simplify, you can. I just want to graph it. So I'm going to leave it right there and say I'm good to graph. Equation number 2. It is right here. It is 6x plus 9y is equal to 12. Again, I need to solve it for y for my calculator. So let's subtract 6x from both sides. 9y is negative 6x plus 12. Let's divide both sides by 9. And for equation 2, I have negative 6x plus 12 in the numerator, all divided by 9 in the denominator. And I'm okay with that. I just want it to go in the calculator and give me a line. If you want to write this and simplify it, you can. Okay, so let's go into our calculator. All right, and I'm going to go back into y equals and clear out what I had in there. My first equation, again, I'll use my fraction bar, was negative 4x plus 12, all of that divided by 6. That's my first line. My second line was negative 6x plus 12 divided by 9. And let's graph these two. Whoops, I made a mistake someplace. Go to. Oh, I pressed, looks like I pressed minus 4x, not negative. Let's make it a negative 4x. There you go, that happens sometimes. Now let's try graph. There's the first line in blue. And here comes the second. Whoops, maybe I did it twice. Did I use that wrong sign twice? I think I did. I did. That's a calculator caught me. I used a minus 4x as opposed to a negative, and it said, no, it's a negative. Let's try that again. There's my first line, it's in blue. Here's my second line, it's in red. And they're pretty close in this screen. I'm not sure how I'm zoomed in. Let's take a look at my window. Oh, I'm not in the standard screen. I'm gonna do zoom and go to the standard window. Maybe that'll help a little bit. This is -10 to 10. And there's the first line, and there's the line parallel that looks really close. I'm gonna do a quick zoom in. There we go. So we can see they're parallel. Let's do a quick zoom in, and I'll just zoom in right where it is at the origin, and maybe we get a little better view that there's a space between them. There's my line 1. Oh yeah, there we go. And there's line 2. And so now you can clearly see that space between them, and the space between them is not changing. Those two lines are parallel. So we can say, it said solve the system. Well, lines are parallel. What does that tell us? I can solve the system. There's no solution. Those lines never touch, so there's no solution to them. Okay, let's take a look at one more example, example 3, which is an example, of course, if you're following, this would be an example of one line on top of the other. Again, I'll note this is equation number 1 and this is equation number 2. And I'll also note that equation number 1 is already written in y equals form. It's actually written in slope-intercept form nicely, so we'll just leave it. We'll just graph it like it is. Equation number 2 is written in general form or standard form, so we need to solve it for y. I'll subtract 15x from both sides. So -15x plus 10. I'll divide both sides by -5. And again, I'm not going to get too particular. I just want to divide the right side by -5, just so I can put it in my calculator. Let's take a look. Remembering that I'm not in the standard window. So I'll go back to my y equals, and we're going to clear those two out. And my first one was simple. If I remember right, it was 3x minus 2. I had to look at that again. So this is 3x minus 2. That one's done. The second one is here. Get out my fraction bar. Press the negative key this time, so I don't get that error. Plus 10 divided by -5. And let's graph these. Oh, they're not in the standard window, I forgot. Well, there's the first one. And the second one should come out right on top. There we go. The red line is going right on top of the blue line. Okay, so I'm in a little bit smaller window, but you can see it graphed right on top of one another. So, what do we know? Solve the system. Well, the lines are coincidental. One on top of the other. That tells me that I have infinitely many solutions. So there you have it. How we can solve a linear system in two unknowns using graphing. A fairly simple, straightforward technique using our graphing calculators.